Now what we need to do is bring some of the bits together. We need to plug it in. We need to test it, make sure it's going to work. So for our first test, we're going to use on the Arduino Nano, we're going to use our first code. This is going to simply cycle. What it's going to do is push the motor backwards and forwards, just to make sure it's moving, to make sure there's not any problems or anything that we've missed as we're going through. Everything that's complete with the kit, you'll also find a wiring diagram as well to make sure that everything's where it needs to be. Now what I'm going to do is plug in my servo. Now an important thing about a servo, it needs a signal, it needs power, and it needs ground. On these ones, you'll find the signal is yellow, power being 5 volts, or depending on how you're going to run your motor, is red, and ground, in this case, is brown. So match your corresponding cables. So this is red and brown for your ground, and then for your signal, again, match the yellow corresponding cable. You'll notice mine are a little bit different, but what you will have is corresponding colours, and these will be, again, brown, red, and yellow. And we're there. We're now at that first stage. We've now got it. We've built it. It moves around the axes like we want it to. And what I'm going to do is I'm just going to be gentle and ensure that your power bank is fully charged. And I'm just going to plug it in. Success! Now what's important here, what if I move my arm here? See? I can move around. What this actually means is that the servo moves around someone's arm, not into someone's arm. So we've been able to do this safely and efficiently. And finally, we've got this built. We've got the Exo built, and what we're now going to look at is introducing the potentiometer. Now, a potentiometer, it sounds really sophisticated. Now, a resistor. In electronics, you have a resistor. What it can actually do is resist current flow passing through within it. It can slow things down. It's kind of like a tying the belt on something to actually slow the process down. Now, if you have a resistor that you can change that depth of how much current can flow, you can actually do some really good stuff with it. And I'll bet you, a lot of you have already used one. When you use something like a dimmer switch in a house, you turn it to get brightness and lower the amount. However, we don't just have to use this to turn on lights. We can also use this to control the position of a motor. This is the potentiometer. What we've actually got, one side is we've got current where it flows in. The other side, we've got ground, and then we've got the output that's coming. What I'm going to do is plug in my USB, and this, touch wood, works. So what you should get is this. However, now when you first plug it in, you may find that the servo moves quickly into position, and it's all about where this little dial sits. To test that this works, to make sure it's going as you want it to, just twist it gently. Very gently. If you twist this too quick, it will slam out of control. Just gently. And what you'll find is that the Exo wants to move. Now granted, when I'm using this, it's using power. It's going to start pulling out a bit. But gently turn it left to right, and you'll find that the Exo is now working. So we've now built it. It works. It's exciting. Am I right? I'm excited. What we need to do now is we need to think about impedance control. In exoskeleton design, when we do this, we approach this in many different ways. You can use human electrical current that passes through muscle. Now, it may be very tiny, and it is super, super tiny, But what some are aiming to do, and some not aiming, but some do, is they actually read some of these micro signals that are coming through from muscles, and they times them out to make them nice and big so we can work with them, and then we use them as a control system. This method is called EMG, electromyography. Myo, or myo, as one of my students once told me, meaning electricity of the arm. And what this does is it allows us to read it and actually drive something with it. However, researchers, developers are still working to make this as accurate as possible. Lots of brilliant people out there, some of the people that you'll have met or at least seen on this, they've been working to fine-tune this and to make this even better. But at the moment, what a lot of people do is to use a method called impedance. Impedance, summarized, impedance basically means when I push my arm, if I push my arm forward, what I'm aiming to do is to cause a little change. When it moves, ever so tiny movement, and it causes the motor to move. We can work with that. We can work with this to our advantage. What we do is we have this extra telescopic piece. This is going to connect. I'm just going to hold it in place so you can see it. So this will connect between here and here, like that. And when I go to move the arm, what it should do is actually try and move the motor. It kind of works. It does work. But again, there's that resistance there. But this is a method known as impedance. So let's fit it and see how it goes. All I'm going to do is remove the first nut, which is this one. So I remove this first nut. And I'm going to take my little telescopic piece, place this over the top, and I have a washer. Now you'll probably find that your hole in your piece is not as big as mine, just because I think my hole is a little bit too big, and luckily the later designs, this has been modified to be correct. Now it sits on, and I'm just going to gently tighten this up. Again, don't go too overboard with it. Don't be too tight with it. What we want to do is just make sure that it's relatively free. So what we see now is we've got this in position. Now this is telescopic for a reason, and it's because depending on who wears this, depending on where it moves, will depend on this distance across. So what I'm going to do is just fit this onto my potentiometer like so. I'll spin this round a little bit so you can clearly see it. Now again, what this is aiming to do as it moves, it aims to help the arm move. You'll notice there's a little bit of traction. So what I'm going to do now is place power onto it. Let's take a look at what it can do. So you see now, it's now locked in, it's now in position. Now as I go to actually move this, if you can hear, and this is coming from me moving my hands backwards and forwards. This is an impedance method. You know, I'm gently pushing it backwards and forwards, and what the motor's doing is it's seeing a slight change. That slight change causes the skeleton to want to move upwards and downwards. This type of skeleton, because it's an impedance control system, this will be good for anybody in the workplace. Any person who's wearing this when they go to grab something, to help them to make sure that there's no extra loading on the body and that there's no injuries that could possibly occur from that. This is a working, impedance-driven exoskeleton. By now, you've probably realised that engineering is no longer what it used to be. It's now evolving to be a whole new area. Some of the people that you've met so far, some of the people you've listened to so far, should have really opened your eyes to the idea of that engineering is now a bigger, vast area for you to get involved with. Take a little bit more time, let's meet somebody else, and let's see how they use engineering humans in their places.